Hello everyone, welcome to yet another new video of electromagnetic fields. So in this video series we are going to discuss three important topics of the electromagnetic fields. So first we are going to discuss about gradient. In the next video we will see what is meant by divergence, and in the later on series we will discuss about curl. So gradient, divergence and curl are the three important concepts that explains the dynamics of an electromagnetic fields. So through these concepts we can easily analyze how the field, what are the important features of a field, how it actually is in a real life. So through this these three concepts we can get a good understanding about the electromagnetic fields. And in this video we are going to discuss about what is meant by gradient. So gradient of a scalar we are going to discuss today. So these are the things we are going to discuss in the upcoming slides. So we are going to deal with an everyday analogy, and we'll discuss the mathematical derivation for gradient and some physical modeling, and also we'll have some quiz sessions. Now the gradient. What a gradient is all about. Gradient is always taken for a scalar. We know that scalar value, for example, assume a temperature, assume a mass or energy density, air density around earth. These are scalar quantities. But the gradient of these scalar will be a vector, will result in a vector. How? That we will discuss through this. Okay. First let's empathize how we will climb a hill. Imagine you are hiking trail, trying to reach to the peak of the hill as quickly as possible. So if you want to do so, in which direction which you choose? Of course we will choose the steepest path, because through that only we can easily reach the top. This intuitive decision is exactly what the gradient helps us to formalize in mathematics, because this gradient points to the direction of the steepest ascent. Let's get in detail about gradient. So gradient vector is at any point is a scalar field which always points in the direction where the function's value increases most rapidly. For example, consider a conductor, or consider an iron rod wherein which we are applying heat at one side of the conductor or one side of the iron rod. So what we will observe, at the one side of the conductor, the iron rod gets heated up. Slowly when time moves on, the temperature from one side drastically moves or increases to the other side, right? So this is what typically happens in a gradient. Temperature is a scalar field, but when I apply the heat, this scalar field, it increases rapidly throughout the surfaces, right? So it is known as temperature gradient. So the gradient vector at any point in a scalar field, it always points in the direction where the function's value increases rapidly to the most. So it is perpendicular to the contour lines of the scalar field. So while using these physical models like foam hills or 3D visualization software, we can easily trace out how this gradient happens. Okay. For example, if you are another example we can discuss now, which is the for example, if we are in a room with some heat source, the temperature at one point will be, at one particular location will be different, whereas at another place it will be different. Okay, right? So for example, if you are in a colder climate, we will be having some heating places. So near that heat source the temperature will be high, and far away from that point the temperature will be very low. So which is represented by a scalar value. So if we take the temperature value at each point, it will yield a scalar value which is in degrees Celsius. So this collection of temperature values at all points forms a scalar field, and this will result in a gradient. If we observe this scalar value, this will be increasing at a particular direction, which shows the source point where this temperature will be at its maximum. So the gradient of this temperature field at any given point is a vector which has both direction and magnitude, where the direction represents the vector point in the direction where the temperature is increasing most rapidly, and also the magnitude of that vector will yield the length of the vector, which gives the how much the temperature, how far or how quick the temperature is increasing in that particular direction. So now how we can represent this gradient? So the gradient symbol is nebula, or we can say it as del. Okay, so how we can represent this gradient? For example, if it is temperature, let T be the scalar, then the gradient of the temperature will be del dot T. Okay, so the gradient of a scalar field, for example, let V be the scalar field, provides two crucial pieces of information at any point, which is the direction, which shows the greatest rate of increase of scalar field, and the magnitude, which gives the maximum rate of changes, in which direction the rate of change occurs. That will be observed through this gradient. So through this video we have easily observed that what is meant by gradient, how this gradient shows a direction of the steepest ascent, and how it is perpendicular to the contour we can observe from this, and also through this gradient we can easily identify at which direction the maximum rate of changes occurs for any scalar field. So I hope through this video we have discussed about in detail about what is meant by gradient and how it is important in analyzing an electromagnetic field. So in the upcoming videos we will discuss about divergence and another important concept in curl. So thanks for listening to this video, and we'll meet in the next video. Thank you.